So first, what we're going to talk about here are what are called the undefined terms of geometry. There's three of them. It's points, lines, and planes. So they are kind of progressively built on each other. So a point is the undefined term that has no dimension. Okay, and it's simply used to indicate a position or location. Okay, and so when you see, this is the illustration of a point, and when you see a point, it's labeled just by the letter that's connected to it. Right, so the points are just like sort of that starting building block of geometry. Okay? So if you string a set of points infinitely in a straight arrangement, then you get the next element, which is a line. A line's going to have one dimension. Oops. That dimension is length. Okay, and it does extend infinitely. And so if you just take an infinite number of points and just string them back to back to back to back to back, eventually they form that straight line. Okay, so what you see right here is the representation for a straight line. You'll usually see the arrows on both sides. And you'll generally see some points labeled on it, but again, there's not just 3 points on this line, right? There's an infinite number of points there. In fact, there's an infinite number of points between A and C. And those are just representations of some of them. When you name lines, you take any 2 points on the line in any order, so A and C, and you put a symbol of an arrow over it. AB would work. The other direction as well, CA and CB. And you can also take BA, let's see, BC. So those would be the different ways that you can name that line using points. In addition to points, you can also use a cursive lowercase letter usually, like the N. It tends to come from the middle of the alphabet, although it doesn't have to. So when you see that N written there, you might also see, and it's not written here, but if you have like L1 with a subscript, oftentimes like a capital L with a subscripted number will indicate a line as well. It should be intuitive. If it's something that's different than what you see right here, it should be relatively intuitive to see a line being represented. Okay, now if you take an infinite number of lines and you string them side to side or like right next to each other, what winds up forming is this next element called a plane. A plane is going to have 2 dimensions. And those 2 dimensions are length and width now. It adds a second dimension. But there is no depth to a plane, so a plane's not 3-dimensional. It doesn't have the depth to it. And just like a line, a plane's going to extend infinitely as well. So what you see here in this diagram, the pink part of this is the plane. And when you name a plane can be named with a single letter. And again, it will generally be some kind of, it's not really cursive, but it'll be some kind of italicized letter. So this could be called plane J. It may also be named using points, and if you name it using points, you have to pick any 3 points that don't fall in a straight line. And so you can call this plane AB, but you can't call it ABC, right? Because ABC fall in a straight line. So those aren't unique to one plane. I'll kind of talk about that a little bit later. Okay, but those could be contained in multiple planes. So in order to name a plane, it has to be 3 points that are not in the same straight line. So you can take A, B, and any other point that falls on that plane, right? It can be K, G, D. It can't be E. And H is a lowercase letter representing that line. So H doesn't represent a point. either. So here, if we say plane ABD, and any combination of 3, right? And so when you're naming this, you can use 3 points not in the same line. Now, if we come back up really quickly, let me talk about a line really quick. So if you're using Chrome, how many of you are going to tend to use Chrome for your browser? Again, most students will just kind of like default to Chrome. I strongly encourage you use Mozilla Firefox. You can see the line symbols are one of the things that doesn't quite show up on Chrome. On Chrome, it would look like this. It would say AC with the line symbol after it instead of on top of it. Okay, so you got to be careful with that. If you look at this, so this is a Chrome browser. If you look at this on your iPad using Safari browser, okay, there's a strong chance that it looks like this. And I have to zoom in to do it because what you would see is, oops. It would be teeny tiny and just right above the symbols the letters that it would almost look like it's just a dashed line in between them. But that would be what it might look like on a Safari browser. So if you are doing problems on your iPad or using Chrome browser, you might have to just be aware, like you can zoom in a little bit to see, does it look like there's an object in that? On the like when you look at something like this is what it looks like in the Firefox browser, which is part of why I prefer that and I recommend that. So just be aware of that, and most of the time you will have opportunities to do your work in my presence. And so if you have a question about it, please just ask me, and I should be able to answer those questions for you. Okay. All right. So see if you can, base on those items that I just talked about, see if you can answer the questions to the right on this slide. And can you fill in and choose the correct answers for each of those items? All right, so if we look at this first question, what's another name for line BF? Well, if you draw a line between the points B and F, it's this line right here. And so picking a name for this, what would be one example of a name of that line other than BF? FB. You can just switch the order with the line symbol over the top. And then what else could you use? I don't have your guys' names down yet, so BD, perfect. BD with a line above it, or DB, the order doesn't matter. And so those would be how you can write the lines for that. You can also say F and D, right? That combination. So FD or DF. So those are the different ways that you can name that specific line. Okay, so if we look at the next example here, AD. I want you to, if you didn't quite get the first time through, and see if you can answer what would be another name for line AD. Okay, so AE is one possibility. What's another? Okay, you can switch the order of that. DA, you can also switch the order of E and A. And then the final way that you can name this, or the final ways, the combination of which two letters? D and E, or E and D. Again, that order doesn't matter. Any 2 points. Now, if you see 3 points used, it's incorrect notation. If you see 1 point used, it's an incorrect notation. You have to have exactly 2 points when you name a line. Okay. All right, if we look at the next example here with this plane, you want to find what's a correct name or correct way to name that pink plane. Let's just go through one by one and see yes or no. So BAC, can BAC be used to name that plane? No. And the reason for that is you can't use the same line. right? And because if you took A, B, C, and you don't have to draw this, but I can draw an infinite number of planes that also pass through those same 3 points. So you can't use those 3 points to name the plane. It has to be specific to one. In order to name a plane, it has to be specific to just one. So a straight line doesn't work. So plane BAC is no. What about plane J? Yes. That's that kind of cursive letter or the italicized letter. What about JGA? So is J a point? So right here, this does not represent a point. Okay? If it represented a point, you would either see the dot with it or it would be the regular non-italicized letter. So J is not even a point, so that's not going to work. Okay, what about GKB? G, K, and B, are all those in the same pink plane? Yes. So you can name that. And then finally, A, G, D. So A, G, and D, are those in the same pink plane? Not in the same straight line, though. So yes for that as well. So those would be the ways that you can name that plane. All right. Questions on those three? Those are the basic elements of, they're called the undefined terms or the building blocks of geometry. Okay, so again, you might see these being called building blocks. All right, the next types of elements are sort of portions of what you see right here, and mainly just portions of a line. Okay, and these are segment and ray. So we'll go through definitions first, naming conventions. So the segment is just a portion of a line that's between two endpoints. So here is your representation of a segment. When you name a segment, you choose the two endpoints and you put just a segment bar over the top. The order doesn't matter. So BA or AB with a segment on top of it represents segment AB. Remember, an A and a B like this is going to be the distance from A to B. Okay? And this same thing, right? BA, same thing. If it doesn't have the bar or symbols over the top, it's just representing a distance. Now, a ray is also a portion of a line, but it's not between two endpoints. It's designated or marked off of one. So here you have a portion of a line that extends from one single endpoint. That endpoint is referred to as a vertex. And you see two different representations of rays here. And rays are a little more unique in that the order that you write the points does matter. Okay, so when you write when you name a ray, you have to start with the endpoint. Okay, so this is ray AB with a arrow symbol, always points to the right. So when we look at this next ray down here, that next ray is not ray AB. Ray AB means that the vertex or the endpoint is A and it passes through the point B. This next one, the endpoint is B and it passes through the point A. Now notice that the ray itself physically goes to the left, but the symbols go to the right. The symbol is always going to go to the right. So something like this right here, that's not a correct way to name that. Okay? It has to point to the right. And then the final definition from that sort of region of section 1.1 are opposite rays. Opposite rays are considered two rays that share the same endpoint and form a straight line together. So once again, here's the representation of two opposite rays, and the actual opposite rays share which vertex, or share which point, A, B, or C? C. So CA and CB, those are your opposite rays. See if you can answer the question to the right of that. Name all the rays with endpoint B, and then also which of them will be considered opposite rays. So when you are labeling these on the computer, you can just recognize the correct answers. When you're physically writing it down, which again is not going to happen like for most of the assessments in here, but does happen when we go through sample problem or the examples. Okay, but the notations that you use do matter. So when you're naming all the rays with endpoint B, okay, so here we see that one is BA. What would be another? So BC would be another one. Notice the B's start first, and we put our arrow symbol to the right. Okay, another. So we'll start with B as the endpoint, right? So B through F, so this one. Now, is BD a way that you can name a ray? We start with B, passes through D. Yes. Notice in these that BA, BC, those are two different rays, but BF and BD, those are actually two different ways to name the same ray. Okay, so you can name rays multiple ways, but only if you see other points that it passes through. So they share the same endpoint, they pass through like the different points, but it's all in one ray. So those BF and BD are two ways to name that ray, and it's that third ray that you can name in there. Now, which of these are opposite each other? B to A, B to C, those have the same endpoint, form a straight line. Okay, and so that would be your set that are opposite rays. All right, so again, these are sort of the elements of geometry that we're going to look at. Point line and ray, or point line and plane are the three building blocks. From those, or mostly from the line, you can take a portion of that, create the segment, create the ray. Okay, let's take a look at some of the terminology that's going to be used for relating these elements. And we're going to start with points. What words or what phrases can you use to relate sets of points? And the first type is we're going to name them as collinear, non-collinear points. Collinear, if you look at sort of the makeup of the word itself, co or col means together or with, okay? And the word line is embedded in collinear. This just means that they're points that can be contained within the same line. Okay, so if points are located in the same line, they are collinear points. If not, oops. So if they cannot, then they're called non-collinear. Again, the word says it, right? No or non, col, together or with, the same line. So not within the same line are non-collinear points. So when we look at the set of collinear points, first of all, and this is the trickiest one, no matter where any two points are located, can you always connect any two points with a straight line? Yeah, that's why I put the word can here. Okay, so if you look at P and T, are P and T on the same line that's actually drawn in that diagram? No. But can P and T be contained in the same line? Yeah, it is possible to pass a line through P and T. So those are any set of 2 points are considered collinear points. Now, normally the collinear points are going to be sets of 3 or more. Okay, so once you add that third point in there, now it's more specific. So what 3 points are in the same straight line here? T, X, Y. Okay, but again, if you take any 2 of those points, so any 2 points like Rx and Ry, those are also sets of collinear points. But so read the line or read the question carefully. Sometimes it might say which of these is a set of 3 or set of 4 collinear points. If it has a list with only 3 in it, even if they are collinear, it's not that set of 4. So just make sure you're careful with that. And then when you get to non-collinear points, in order to have that, you have to have at least 3, right? Because any 2 points are collinear. And so if we were to take T and X as the first 2 points, what other point could I add to this that would give it a set of non-collinear points? One possibility would be P, right? Tx and P are non-collinear. I could have also chosen R for that. Those would be 3 points where 2 of them are in the same straight line, but the third one's not. All right, so based on that information, I want you to see how you would answer the question to the right. Can you identify? And the answers are either collinear or non-collinear. The drop-down will be collinear or non-collinear. It'll have a third option when you look at your homework problems. The third option will be neither, but that's not an option. That's just a distractor. Okay, so a set of points are either collinear or non-collinear. They're never both, and they're never neither. Look at these examples. P, X, and Y. Are those collinear or non-collinear? X and Y are the same line, but P is off of that, so non-collinear. I'm just going to label it NC. Okay, TP and Y. So TP with Y, non. What about TX and Y? Co. And then X, Y, and T, just a different combination of those same, so also collinear. Okay. Questions on those relationships? Okay, so non-collinear, collinear basically relate the elements of points. This next relationship or set of relationships is going to relate multiple types of elements. So you can have coplanar lines, you can have non-coplanar lines, rays, any portion of a line, segments. And so all of the different elements that we have can be coplanar or non-coplanar. And again, embedded in the word is the definition. Okay? So co means together or with. The word plane is embedded in that. So coplanar points are points that can be contained in the same plane. Whereas non, together or with, plane. So these non-coplanar points are points that cannot be contained in the same plane. So when we're talking about coplanar points, that's kind of what you're looking to identify if they can be first. And so just like with the collinear, okay, any 2 points and any 3 points, those can always be contained in the same plane, right? Any 2 points are a straight line. A line is a planar figure or planar element. If you connect any 3 points, no matter where they're located, it forms a triangle. A triangle is a planar figure. It's a flat surfaced figure. Again, a plane is a flat surface. In fact, let's see, back on definitions. Okay, one of the things here, probably best to say, is a plane is a flat surface. It's not going to be a curved surface. Okay, so planes are flat. They look like rectangles or parallelograms in the symbols or the representation. Right, so it's only when you get to points that are outside that they might fall on or off. So if I looked at points, let's say L, M, and O, L, M, and O, those fall on that shaded plane, right? So if I'm looking for, here I'll put L, M, and O here as well. So if I'm looking for a fourth point that is coplanar, if I take that set right here, what I see is N is also in that plane, P is also in that plane, and so is K. So I can take any of those 3 points, okay, and those would also be considered coplanar with that. So if I added P to this, or N, or again K, those would all be a set of coplanar points. But if I'm looking at this plane right here, again, taking those same set of points, right? Oops. If I have L, M, and O. So if I take those points, I want to find a point that's not on that same plane. So what I can see is J is not on that plane, Q is not on that plane. Those are the only 2 possibilities I have. So as long as I choose one of those 2, either J or Q, that's going to be my set of non-coplanar points. All right, so I want you to see now, this one is a little more challenging. Okay? So this is one that's like the students find more confusing generally. Okay, but I want you to see if you can answer the question on the right. And here you're choosing now coplanar or non-coplanar. Once again, it says, and there's an option of neither, but that's just a distractor. It's never going to be neither. It's, points or elements are either coplanar or they're non-coplanar. They're not both, and they're not neither, and make you think that you can't do geometry. Okay, so it is a confusing topic. It's very minimal. If there is a question about it, again, hopefully you can leave a note to your future self enough to get at least partial credit for this, because if you even just look at what I put in parentheses there, coplanar points, any 2 points or any 3 points will always be coplanar. So even just using that, you know that this set and this set are coplanar. Okay? You don't even have to look at where they lie on the graph. It doesn't matter where they lie. It doesn't matter if the 2 images, right, because you see a shaded plane and you see a non-shaded plane. It doesn't matter whether the points are on, like where they are. If you see 2 points or 3 points, you know for sure those are coplanar. And so already you have partial credit here on a question like this. Okay, so now once we establish those based on the rules, let's move to the 4 points. So the easiest way to do this is just pick 3 points that fall on one of the planes. Okay, so, and you can really just kind of start going through if you want. So J, Q, K, those are all 3 points on that unshaded plane, right? So then we look at N. Is N also on that unshaded plane? So it's hard to tell here, okay, but that shaded plane is coming at a different angle than the unshaded plane. So that dashed line means that point N is actually falling behind the unshaded plane. So point N is only on the shaded plane. It's not part of that unshaded plane. Like I said, this is where it can be confusing to students. So this would be like the following. Okay, it's kind of like pieces of paper intersecting like right here. Okay, if the unshaded plane is this and the shaded plane is this, N's going to fall down here on this corner underneath or at the bottom. Okay, so N does not fall on that same plane, so this is considered non-coplanar. Okay, let's look at O, M, K, and J. So I'm going to erase these. I'm going to pick any 3 points that fall on one of the planes that I can specifically tell. So I have O and M. Those are both on this shaded plane. I have K also on the shaded plane. And I have J. Is J on that shaded plane? No. You can see it sits above it. It's on that unshaded plane only. And so here, a set of non-collinear points, or non-coplanar points. Okay, I'm going to go ahead and erase and do my next test. Again, just start O, J, and Q. So when I look, O is on the shaded, J and Q are on the unshaded. So right away, I probably have my answer anyway, but I'm going to go ahead and list J, Q. I see that P is also on that unshaded, but O is not. So once again, non-coplanar. And then my final example when I look, take any three that are on one of the planes that's like specifically. So O, M, and N, these are all on the shaded. So I'm going to start with those. Point Q, is that on the shaded? No. Now, it's not always going to be like in this sense. I mean, this will definitely mix around, and the version that you get might have two coplanar and four non-coplanar, and might be mixed 3 and 3. It might be mixed the other direction, 2 and 4. And so you don't just think that you're going to find two coplanars and the rest are non. It will vary from that. Okay. All right. Final concept here has to do with just the relationships of certain elements, okay, and the terminology. So endpoints, there's no definition to it, just examples. A segment has these two endpoints. It's exactly what the word says, right? It's a point that falls at the end of the element. Array is going to have a single endpoint, and depending on which direction it's going, again, in this case, it's either the point A or the point B, depending on how that ray is opening. Okay, intersections, though, they do have a definition. An intersection is the set of points that are shared by elements. And so one of the things that you are going to be asked to find, and it's just something that is pretty intuitive when you look at the diagram, and that is if you have two lines intersecting, the shared element is a single point. Okay, if you have a plane intersecting with a line, that intersection can be a single point. Okay, but you can also have, so if you have like a box kind of representing the intersection of three planes, okay, you can have a line that just is contained in the plane. So this is not really an intersection. This is an intersection of two planes intersecting at a line. Okay, so two lines intersect at a point, a plane and a line intersect at a point, two planes intersect at a line. Okay, and so these are just the intersections based on what you see. And so see if you can answer that last question, please, based on what you see. All right, so what's a point that's collinear with point A and C? The other point that falls in that same straight line is B. Here it is. Okay, what's a point that's not on plane CAG? So CAG is that pink shaded plane. So the point, what's one of the points that's not on that? E. You could also have chosen F, either of those. You just need one. I put both here, but just need one. And then what's the intersection of plane CAG and line FK? Those intersect at